So, what do you understand about SPC? Before I proceed, what do you understand about SPC? It was from the run chart, but when we put the limit, upper limit and lower limit, and we have the mean there, so it helps us to control the process. That's the purpose of, that's the idea of SPC. It was introduced by Dr. Walter Sheward in 1931. It's a very long time ago. And it was ignored in the West after the Second World War because West were celebrating their championship in the Second World War. But during rebuilding of Japan after the Second World War, Dr. Walter Sheward taught Japanese on how to use the SPC, and it was adopted. And subsequently, they developed it into total quality. So why we use SPC? This is the rationale. Why we use SPC. First, the variation, process variation. We want to control the process variation. Then when we know the variation, definitely from statistics, we know the variance. Then we can make possible Kaizen to reduce the variance. Or maybe we detected outlier in the SPC. Those who are outside the upper limit and lower limit, outside the limit, that's outlier. So that's cost to us. Because when we reject that outlier, we eliminate that, not just the sample that we are eliminating, but we are eliminating the log. For example, if the sample is only for that particular subgroup only 5, not just that 5 we reject, but remember that 5 represent to 1,000 unit maybe. So 1,000 unit has to be rejected. So you imagine how much the loss to the company. Or maybe you said, okay, no problem, we can do the WIP, work in progress, we repair it. So that's also cost. Because you have to spend your workforce for repair, which is unnecessary if you have improved the quality. And then maybe you want to do the prediction. The SPC result can be used for prediction as well. So you can use this to determine your process capability as well. Your process capability. You want to know your level, whether you are world class or vice versa. And definitely, when you know your status, you can use this SPC for eliminating muda. Japanese word, muda. Maybe you can reduce cost on the inspection as well. So why we need SPC? Also, we want to elevate the quality of the product and lowering costs. We want to reduce costs. This is what I've shown just now. Normal distribution chart. But what is this? Sigma is the standard deviation. 3 multiplied by standard deviation. In an ideal measurement for this SPC was based on 3 sigma, was based on 3 standard multiplied by standard deviation. Why 3 sigma? And the formula also based on 3 sigma. Formula for the upper limit and lower limit. Why 3 sigma? Any answer for that? I want to ask Jeffrey. Do you have answer? Why 3 sigma?
Not really sure, doctor.
Amira.
Yes, Prof.
Why 3 sigma?
To reduce.
No, the keyword is economic. This was decided by Dr. Deming and Dr. Walter Sheward in 1950s. Can you Google from the internet why 3 sigma? It is there actually. Let's Google.
It is because 3 sigma to control limit are used to check data from a process.
There is a rationale there. Sheward set 3 standard deviation limit as rational and economic guide to minimum economic loss. I write down here. Sheward set 3 standard deviation, short form standard deviation, or 3 sigma limit as a rational and economic guide to minimum economic loss. Minimum economic loss. Because if we increase the sigma, so means the reject may be increased. So the beyond economic range, they identify as 3 sigma is okay. So I continue the statement, 3 sigma limit. Limit set a range for the process parameter of 0.27% control limits. So 3 sigma control limit are used to check data from a process and it is within statistical control. That's the reason. So we have to agree this because long time ago, Dr. Deming and Dr. Walter Sheward, they have considered this. This is the minimum economic loss. The minimum one. If we increase then 3 sigma, the loss will be increased. So they can tolerate, industry can tolerate at this range. That's only the reason. So if you look at here, the output shaded, that's the reject. This is the loss due to the poor tolerance. And maybe in the distribution curve, you have a bimodal like this. And here is poor quality. And this is the ideal one that we are expecting. Right and left, 3 sigma. And the target is on the mean. That's what we want, what the expectation. So how to draw this control chart. This is what we have discussed before. This is our mean. And we should be given the standard deviation as well. And this is the limit, upper limit and lower limit for this case. And the hash area is the rejection. Okay, let's go through this example. Initially, it is this normal distribution curve, but in order to draw the process chart, we have to minus 90 degree. Rotate this, become like this. And this mean is here. And this upper limit is here. And this is the lower limit. So later I will show you how to calculate the upper limit, lower limit, and mean. But in this slide, I just want to share with you how does it look like from the normal distribution curve to the process chart. So this is among example for the table that we should put the data in. And if you look at here, sample measurement, this is what we call sample. And each time we take the sample, we call subgroup. And the entire population of this is what we call population. And in the subgroup, we have sample. Denotes by n, small n, and population is capital N. So let's say we have the data. For each subgroup, we take 5 samples for this case. And for each subgroup, we have to sum this. And then we have to calculate the average. Average is X bar. Then we have to calculate the range. Range is X maximum minus X minimum. So this is for X bar R chart. If our N normally less than 6, if I'm not mistaken, we use X bar R chart. But if N greater than 6, we use X bar S chart, where S is the standard deviation. But sometimes in industries, maybe they don't want to waste their time to calculate the standard deviation. They just use R chart, also okay. Why? Because this S and R represent the same meaning, because both will tell you the distribution or dispersion. Doesn't matter if it is R chart or S chart, as long as it shows you the dispersion, it's okay. This is data. We put in the data here. This is the subgroup, as I mentioned before. Then data 24, 27, 28, 33, and so forth. We put the data here. Then we sum all this. We calculate the average for this each subgroup. Then range, the maximum, for instance, this one, 33 minus 24, the range is 9. 31 minus 29, range is 2. 42, 35, range is 7. So this is how we calculate the range. So after we have this, basically we can plot like this. We can plot, but what is the mean? We want to know the mean. The mean is X double bar. Mean is sum of X bar. We have X bar here. We sum this. We got X double bar. Then we divide by how many population we have or how many subgroup we have. 1, 2, 3, until how much? How many? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. How many? I need to count it. 25, yeah, 25. So divide by n. So 25 altogether, I have the mean. And same goes to the R here. We need to total this, divide by 25 to give us mean for R. So when we have this, we can plot this line. Mean for R and mean for mean of mean. Mean of mean. X double mean of mean. Then another question is how to calculate the upper limit. This is the formula. Where is the upper limit? This one. Lower control limit. And here is the upper control limit for R. We use this formula. For X bar and this one for R.
Prof, just want to ask you, we can get the information upper limit and lower limit without calculating it from the data.
We need the X double bar. We need X double bar. We need the R bar. We calculate it from here. Okay? We need this. Then we put into this formula, but what is the E2? X double bar and R bar we have calculated before. But A2 we got from this table. This is just small table. Later I will show you the actual table. So A2 is depend on how many sample for each subgroup. Subgroup. How many sample for each subgroup? For this case, we have 4 sample. We have 1, 2, 3, 4 for each subgroup. So 4. So the A is this one. Because n is equal to 4. And here we have D4 here. For the R, D4 is equal to 2.282. This one. Then after we put it into the formula, we get the upper limit, lower limit for X bar, and upper limit for R chart. Okay, This is when we have only less than 6 sample for each subgroup. This table, this factor for control limit. But later I will show you when we have more than this. So we use this formula. Okay. Before I go further, let's look on the interpretation of this SPC chart. This one is how to calculate the X double bar, R bar, average X bar for each subgroup, range for each subgroup. Then from here, we able to calculate the mean of the mean and mean of the R. We get the line for that and also line for R bar. Then upper limit, lower limit, we calculate using this formula. Then we have to refer to this table. But as a top management, maybe you are not interested with this because this is maybe done by your engineer or you have a computer to do it for you. Maybe you are interested with this. This is normal behavior. Because why normal behavior? Because it is beyond the limit. Although it looks normal, but why this one increase close to the upper limit? And this is good, maybe, but why it run away from the mean? This is the mean of mean, and then it's close back, and then again it's run away. So you want to know this. You want to know that. So we have to check at the game bar. What happened here, here, and here? Same goes to this one. One data point out. This one goes out from the limit. The limit is there, goes out from the limit, becomes outlier. So imagine if let's say this is n equal to 5 maybe, but this 5 represent to maybe represent to one lot, maybe 1,000 pieces. So 1,000 pieces you have to reject because of this. So you must know what is the reason. Before this, it was at the mean of mean. But why suddenly it goes out to the upper limit? So you have to investigate the cause of this poor performance. And this one also out. You have to investigate as well. And this is also interesting. 2 point close to the upper limit. It's still accept, it's still not reject, but it's close. So you have to investigate as well. This one, you must know also the reason, because this is lower limit. Sometimes it's good to drop to the lower limit, maybe. But if we have the fixed tolerance, cannot less than this, cannot more than this. So anything close to the upper and lower, you have to find out the reason why. And this one, it seems like there is a tendency to the upper limit. You have to investigate as well. Cause of sustained poor performance. This one, fast accessing data below central line. Investigate. Increasing, decreasing. Why this happen? Erratic behavior. Sudden change. This one, jumping up and down. Sudden change. So you must investigate all this. That's your purpose as a top management. Maybe this thing, the chart will be done by the computer, but to interpret the information, to find out the point of cause, to find out the point of cause, to find out the why and how, one how. It's your job. Okay, this is about the example just now. This is how to calculate the upper limit, lower limit, and so forth. I've shown you before. So let's do some exercise. Compared to the previous data set, we only have 4 samples for each subgroup. 4. But this one, we have 10. We have 10 samples for each subgroup. This is the subgroup. What should we do? Regardless, the arrangement is vertical like this or horizontal, it doesn't matter, as long as you know, you're able to identify which one is the subgroup. Here is the set of data for each subgroup. So first step, after you have this, you have to calculate the sum. Or if you don't want to calculate the sum, it's okay. You calculate the average using Excel. Average of this data. Average of this. You calculate the average, you got the average. This is maximum, tolak minus minimum. The highest one for the first row, highest is 102 minus the lowest 98. So we got 4. This one, highest is 102, the lowest 98. So that 102 minus 98, 102 minus 98 is equal to 5. That's on the range. Then we total of the above, total this, we total this. This is the total for X bar, total for out. Then how many subgroup we have total? That's the population is 12. So X bar divided by N, 1, 2, 0, 0, 1, 8, 12, that's 100,067. That is your X double bar. This is mean of X bar. Mean of X bar. Same goes to this one. arc bar equal to sum of arc divided by n equal to 68 divided by 12. You got this one. So after we have the x double bar, x bar, we need to have to calculate the limit. If you remember the formula before, you have the formula here. Upper limit x double bar plus minus limit x double bar plus minus a to r. Positive for upper, low, negative for lower. How to get the E2? It depends on how many sample we have for each subgroup. We have 10 here. So n equal to 10, we use this one. So A is 0.31. But as you look at to this table, this one. For the arc chart, when n less than 6, we don't have lower limit for the arc chart. We only have upper limit. But starting from n equal to 7 and above, we have lower limit for the arc chart. So that's why statistician recommended that if we have more than 6 data or more than 6 sample in each subgroup, they recommend to use X bar and S chart. This one, X bar and R chart. But in practice, it doesn't matter. You can still use R chart if you have 10 sample for each subgroup, no problem, because it just tell you the distribution only. But statistician doesn't agree with that. It's okay. Let them be statistician. Okay, then we calculate the limit for arc chart as well. So we calculate the limit for arc chart. We use the same formula. This one. Just multiply by R. So D3 multiply by R, that's the lower control limit for R. D4 multiply by R, that's the upper control limit for R. We just multiply like that. D3 is 0.22, D4 1.78. So this is the answer. Upper limit, lower limit for X bar, lower limit, upper limit for R. Then we put the line there for X double bar and R bar. Then we plot the graph. And looking to this graph, it seems like we don't have problem, particularly here. But if you look at to the dispersion, why it is increasing? Although it gives you close to the mean for the X bar, but it is interesting if you could find why this happened. Also, if you have this kind of result, you have one outlier here, outside the limit, we call it outlier. You want to know why. You have to check your process. But when we deal with SPC, when we have this outlier, actually in Dale's book, Dale Besterfeld book, Dale Besterfeld book, they derive the formula. When we have outlier, how we are going to calculate the final upper limit, lower limit. But I don't want to make you confused. We do it in the longer way, where when we have outlier in your SPC, you have to reject this. You have to delete this. When you delete this, what happens is your n reduce to 1. So means your x double bar change. Also your R bar change.
Prof, when we
Wait. When x double bar and R bar change, of course your upper limit and lower limit also change. Okay, yes. What is your question, Charinon?
when we delete it, so it means that the connection of the data from 6 will jump to 8. Eh?
Now, you have to calculate again. You have to redo this again. You have to calculate this again. Because you have delete 1, for example. You have delete this one, for example. So your total of population is reduced.
Delete the whole data, then we
Yes, delete the whole data, and then you have to redo again.
Okay.
Okay? You have to redo again. So for example, this one, delete one, I have to redo because n, capital N reduced into 1. So it changed the x double bar, change the R bar. So the limit also change. Then plot again. After I delete subgroup 7, I delete this one. Then I got the new limit. This also the new one. Data remains the same. Still this x bar. But when I plot this, suddenly this one outlier. So again, I reject this one. So I delete subgroup 2. Delete 2 subgroup now. So I delete subgroup 2 and 7. Calculate again, new upper limit. Sorry. This one also new. Plot. And okay. You imagine you have deleted 2 subgroup. Again, if each subgroup represent out of 1,000 parts, you have deleted, you have to reject 2,000 parts now. So how much is the cost? Okay, this is on SPC. And these are the formula for variable control chart. Just now we're dealing with the R, X double bar R chart. So X bar R chart. These are the formula. Upper limit, lower limit for R. Upper limit, lower limit, upper limit for R. Lower limit, upper limit for X bar. As recommended by a statistician, if we have more than when we have more than more than 6 sample in each subgroup, they recommend us to use standard deviation. So for standard deviation, we can use this one. This is for the X. And of course, for the, instead of arc, we can use S. This, and the formula is different. Instead of we use D3, we use B3 and B4 for the standard deviation. Besides standard deviation, statisticians also recommend to use median. Why is median? Why is median? Come on. In the diploma class, I will teach my student how to calculate the median. But for master class, I don't want to teach that. But of course, you can use Excel to give you the median. Median is subject to the population of the data, basically. The tendency of the data is related to the density. So for example, in Malaysia, we have B40, M40, and T20. So the calculation was based on the median income. So for the B40, for example, if majority of the population, their salary is around 1,000 plus. So it will give us the median for B40 is 1,000 plus. So it's subject to the which group has a higher density. That's a median. Okay, this is the table, the full table actually. For A2 is for the X bar chart, D3, D4 is here, D3, D4 for our chart, A2 also X bar chart. And we have also E here, E for this E, you can use this one as well. If you want to use, no problem. But again, I repeat, if we have more than 6 sample in subgroup, you can use X table, S table. This is the formula again. And this is for S chart. Remember, for S chart, we need the B3 and B4. And for S chart, B3, B4 is here. And we have A3. A3 is for this one. So if you want to draw X bar as R chart, you can use this one. If you want to draw X bar as chart, you use this chart, this table. Okay, NP chart, I don't want to cover on the NP chart. That's for attributes data. Okay, I think I stop for a while.